Greetings to our EcoCast podcast audiences. Welcome back again to the new episode. And we are back here with Professor Gourav Bhowmick, who is an assistant professor in the Department of Agricultural and Food Engineering Department. He is currently working at a prestigious Indian Institute of Technology, Kharagpur, and has been working there since 2021 with research focus on the advanced aquacultural techniques and hybrid bioelectrochemical system-based wastewater treatment technologies. Before joining IIT Kharagpur, he pursued his postdoctoral research at Ben-Gurion University of the Negev, Israel. He aims to develop a bioengineering interface for aquaculture in areas like design of aquaculture facilities, commissioning, operation, material selection, and their uses in recirculatory aquaculture systems. He also focused on denitrification, phosphorus removal, biogas production in line with residual resources engineering for environmental remediation. Another research area of his is the smart aquaponics system for urban farming. He has already published more than 35 international journal papers and several book chapters. He also presented and co-authored at more than 3 dozen international conferences. He was awarded by Gandhian Young Technological Innovation Award, which is GYTI award, in 2016. As for within top 15 young scientists, Indian scientists basically, at President's Estate, New Delhi, are felicitated. Dr. Bhowmick is quite enthusiastic about exploring innovative solutions in areas related to smart farming. He is committed to inspiring the next generation of students, fostering a passion for environmental stewardship and cutting-edge technologies. Together, the goal of his team is to work towards a greener and more sustainable future within the limited capacity, and also help in disseminating knowledge to early career technologists like us and entrepreneurs around the globe. Well, Dr. Bhowmick, welcome back to our podcast series. I think you were already here when we were starting the podcast, so I will use this word back because you are already associated with our lab in many sense, I would say. So welcome, Dr. Gourav, to this wonderful episode, and looking forward to your nice talk.
Thank you so much. Thank you so much, Dr. Pratik Kumar, and thank you so much the whole team who is involved in this EcoCast, this E2C podcast series. And I'm really interested. I'm really happy and really privileged to be a part of it today. And I hope the audiences will be I'll be able to share some knowledge with the audience, which will be helpful to this podcast series.
I'm sure it will be a pleasure. So, Dr. Bhowmick, now that you have worked so much in the field of Agri-Aquaculture System, could you please educate our audiences in brief on how the 3D concepts are influential in this exciting field of research, and how is it going to be a game changer?
Well, to start with, I would say this 3D Agri-Aquaculture System is not a very famous term as of yet. So I only started using this word now, here and there recently. So basically, what is this 3D agriculture or a 3D agri-aquaculture systems are? These are nothing but a conglomeration of 2 different techniques. One, the basic aquaculture practices, and the second is the hydroponics kind of systems, where we normally go for vertical farming and vertical soilless farming of different crops, and where the nutrient will be supplied through the waste that is being generated by the aquaculture practices. So we are literally having a win-win situation here. We are getting rid of the waste coming out of the aquaculture practices. At the same time, we are converting this waste into wealth by producing the nutrient for the crops to survive and to do this kind of 3D agriculture practice, 3D agri-aquaculture practices for even urban farming level as well. So that is what I am doing majorly at IIT Kharagpur, researching on different types of 3D aquaculture systems, namely aquaponics, aeroponics, fogponics, flockponics. So there are different varieties of it that I'm researching on right now, and I'll be very happy to share some of these knowledges during this podcast. Yeah, so I'll be very happy if someone has any question.
Thank you, Dr. Bhowmick, for this amazing introduction and setting up the stage for the podcast. Sir, my first question would be in context of the urban high-rise buildings and increasing concrete jungles. The question is that how can aquaponics and small-scale urban agriculture be integrated into sustainable building designs to enhance environmental sustainability and promote green living? The question would be in context with this Green Building Council and like the green buildings which are coming up where they use less of the electricity and less. They design the building in a way that they are sustainable and green in itself.
Thank you so much, Wasim. So it actually makes sense. Actually, if I tell you the strategies of this high-rise building and to make it a green building, or when to get rid of the urban heat issues and all these things. So 3D agri-aquaculture systems can play a major role here. First of all, to start with, if you know that majorly the integration can be like a rooftop aquaculture systems or aquaponic systems. We can go for indoor farming of the smart buildings. We can go for this green facades and all. These vertical aquaponic systems can be integrated in these building facades, which can act as a living wall. And if in this way, it can actually reduce it can improve the air quality. It can reduce the energy cost by acting as an insulation layer. And further, it can produce the food for the people living in that nearby vicinity. Other than that, it can be worked as multifunctional space for recreational activities as well, such as terraces and community garden to promote the green living. It can also be used as it can be integrated very closely with the building infrastructure, which is one of the major reason why like now smart cities around the world, they are thinking about integrating this kind of aquaponic 3D agriculture systems. First of all, the water recycling. The wastewater which is coming out of the residential unit can be treated and reused in these aquaponic systems. Plus the energy, the waste heat from the heating, HVAC systems, what we call this heating, ventilation and air conditioning unit, that can also be used. That temperature or the heat can be also used to ensure in the aquaponic systems, and especially in the greenhouses, to maintain control the temperature for year-round productivity. Other than that, we also request the city planners to integrate this kind of 3D agriculture systems with the urban planning to align the building designs with the urban sustainability goals. And also it can be promoted further. What if we can actually if we talk to the local this policymakers or the legislative bodies, so that they can integrate this urban planning along with this 3D agri-aquaculture systems through these different tax benefits, joining bonus or green certification program, etc., etc. So there are environmental benefit like carbon sequestration, urban heat island mitigation, waste reduction and biodiversity conservation. At the same time, as I mentioned, the economic benefits are also there. Like we can have a low-cost food available in the nearby vicinity. Energy saving can be done. It can also drastically increase the property value. If you can say, okay, my building is a green building because I have integrated I have made some very minimal integration, which can actually give us a very high return in terms of food value, in terms of green ethical values as well. So this way you can actually promote the 3D agriculture systems, and actually it has been done all over the world, and that is how the future is, how it will look like. Even for India, we call it future, but obviously there are countries which actually making it realistic even at this present time. Countries like Netherlands, Israel, Dubai, etc. UAE, etc. So I hope I answer your question, and yeah.
Yes, sir. Thanks so much. That was like a really elaborative one. I have sort of a small supplementary question, which will like sum up what we discussed right now. The question is that while we consider the urbanization, and what will you say about what are your views about how can this recirculatory aquaculture system and residual source engineering contribute to the development of smart, sustainable ecosystem that will balance out the environmental needs with the growing urban demands and the urban growth?
So, see, there are, if you talk about the RAS system, the recirculating aquaculture system you're talking about, right?
Yes, sir. Yes, sir.
Yes. So, RAS system, the recirculating aquaculture system, it has a lot of additional benefit to start with. It's majorly used for to treating the wastewater, which is a major issue of the aquaculture practices. It is optimize. It can be used for optimizing the space in the aquaculture systems, because most of the aquaculturist has a lot of one of the major problem that the most of the aquaculturists they face is the recycling of the water. I mean, like the exchange the water with the freshwater sources, because the fish when we culture it in a high stocking densities, those fishes or any other aquatic species, it actually produces a lot of waste, and those are very high in nitrogen content. I mean, like basically nitrogen waste. So those has to be treated or somehow being replenished by the freshwater very frequently, which comes as a major drawback of this kind of system. So this recirculating aquaculture system comes to the practice for the last couple of decades now, coming up with even in our lab also we're working on different bioreactor, different type of units that can be supplemented with the recirculating aquaculture system that can increase the productivity of the aquaculturist and all. And another term, as you have used, the residual resource engineering, or RRE in short we call it. So in residual resource engineering, our target is to use the waste, right? To use the waste that is being generated at source or at the point of application. So it can be organic waste. We can convert this food or the organic urban waste into biofertilizer, biogas, and compost for this urban farming, for this 3D agriculture systems. We can treat the water or the grey water or the nearby vicinity and to use it in a RA system or recirculating aquaculture system. We can use the waste heat generated in the urban infrastructure to regulate the temperature in the aquaculture or the agriculture systems. Normally, whenever we design these 3D agriculture systems, we normally place it inside a temperature control greenhouses. That would be better. I mean, like, I'm not saying this is bare minimum. That it would be better to get more control over the system, to get a more desired output from the system. So this can be done with the resource with this kind of residual resource engineering and all. So when you talk about the integration of RAS and RRE, this both the system in urban ecosystem, it can definitely come up with the good results, and especially in terms of this 3D agriculture system, 3D agri-aquaculture systems, it will definitely come up with the good results, because 3D agriculture system is nothing but one type of RS system itself, because they are also what we're doing, we're treating the aquaculture waste and we're producing some product out of it, and this product is nothing but the crop. And after the treatment is done, the final water that is coming out of those aquaponic system is like almost the pollutant free. That will again put it back to the aquacultural tanks. At the same time, it can be also considered as a residual resource engineering concept also. I mean, like in terms of residual resource engineering concept also, we can call it that we are reducing the waste and we're generating a wealth out of it. So when we do that, this kind of systems definitely can help developing the smart and sustainable urban ecosystem by obviously reducing the environmental impact footprint of the regular regular urban infrastructure. It also enhances the biodiversity in that area. It can promote a circular economy based concept, because you are not only you are converting the waste to resource, plus you are increasing the local production and the consumption cycle by reducing the dependency on the external inputs, like carrying out vegetables and the fishes from the market, and this market also, those vegetables and fishes are coming out from the long range supplies, like suppose from it comes to mostly from the rural areas, and so this dependency can also be reduced. So in a way, this 3D agriculture system is acting as a quite balancing mechanism in between the environmental needs for a proper and sustainable urban ecosystem growth. That's what I think I answered the question, Hossein.
Thank you, sir. Sir, with your expertise in hybrid bioelectrochemical system and sustainable 3D agri-aquaculture systems, what innovative approach do you envision for managing wastewater and conserving water urban farming setups, especially in high density urban areas?
Especially in the high density urban areas you're talking about, right?
Yeah, yes, sir.
Okay. So, I mean, this is actually bioelectrochemical system is a bit outskirt, I would say. It used to be considered as a bit of an outskirt technology when we talk about the 3D agriculture, but we can actually integrate both the systems, as you have correctly mentioned. The bioelectrochemical system is nothing but, kind of an advanced wastewater treatment unit, but at the same time, we can actually gain recover some kind of resource in terms of energy, in terms of some additional elements as well, okay, or some compound as well. So here, when we use 3D agriculture systems, 3D agri-aquaculture systems, we need to convert the nitrogen-rich wastewater coming out of the aquaculture tank into a viable form of nutrient for the crop, right? And that process is done in the bioreactor in general. So that bioreactor is nothing but does the nitrification, okay? Majorly, we try to go for the nitrification process to occur so that ammonia-rich wastewater will be converted into nitrate. So this process is normally done there, and we normally follow the process of nitrification. We try to grow the bioreactor in such a way that it will be grown. So what we can do, we can supplement. This is not the only job of a bioreactor, but there are other nutrients also that can also be converted into valuable byproduct when we do this. This 3D agriculture systems. So why not we use the bioelectrochemical systems? As you have correctly mentioned about the hybrid bioelectrochemical systems, like nowadays we use the MFC MBR systems. Like MFC, it's an abbreviated form of microbial fuel cell, and MBR is a membrane bioreactor. So we use this kind of units, this kind of advanced technologies to convert the wastewater into some valuable byproduct. At the same time, while simultaneously treating that wastewater as well. So why not we use this kind of techniques in our 3D agri-aquaculture systems, and at the end, final output can be used by the crops to be grown comfortably in the 3D agri-aquaculture system. So it has been done, and these innovative approaches are, as you have asked, like it is actually being followed, and even in our lab also we are trying to grow, develop this advanced hybrid bioelectrochemical systems to treat the aquaculture waste, and then we convert supply to the crop bed so that they can consume the nutrients and in its optimal values and all. It's not only in our lab at IIT Kharagpur, but also people from around the world, especially in UK, even there are some private companies in Europe also. They are also started working on it at the integration of bioelectrochemical system and the aquaponic setups, and they are getting quite successful results already. And we are also working on it to make it to the to convert it into a viable product for the general mass production, mass consumption and all. So other than that, we there are some complementary innovations that is also going on in this regard, in this urban farming setup, when we can integrate the bioelectrochemical system and agri-aquaculture systems. We started working on urban greenhouse production and urban and modular farming units in the smart cities itself. So there, this technology that I have just mentioned can be integrated and can be produced in scale. I mean, like, at least the science is already available, but the real life applications are very rare as of now. But I'm very much hopeful that in coming 5 to 10 years down the lane, we'll be able to see more of this kind of units in real life scenario and in practical around our vicinity as well. I hope I will be able to answer the question.
Yeah, sir. Thank you very much, sir. Sir, the hope is same from our end as well, that we're able to see such systems more often in the world. Sir, now India is primarily an agricultural country, as we all know. So, sir, and you have been working from a long time. So the problem generally with soil is the salinity variation in soil, and with fish that are supposedly put in the aquaculture systems is with fish, they have a sensitive response to the aquatic environment, which may change in response to the changes in the integrated systems. So, sir, I would like to ask that how can the varied levels of salinity be catered to by these systems, and also if we put in unstocked fish, would that be beneficial or would that be not beneficial for such systems? Along with it, could you just mention any other challenges that you are facing, considering the area of research that you're in with these integrated systems?
Okay, yeah, it's a very actually interesting question. So I would like to answer first your second question about the unstock fish. Basically, most of the, like, if we talk about when we target some unstock fish, suppose it's rich in omega-3 fatty acids or other protein elements or the essential micronutrients, it overall improves the dietary benefits of our 3D agri-aquaculture system. So it can be actually introduced easily. So if we can introduce easily, if we can introduce this kind of economically productive unstock fishes in our 3D agri-aquaculture system, so there are a lot of benefits we can get. First of all, as I mentioned about the nutritional value will increase. We can use this product, use these fishes or this aquatic species for getting a lot of valuable byproduct that is already there in the market. In the pharmaceutical industries will also be literally jumping for this kind of valuable unstock fishes. If we can grow it in a 3D agri-aquaculture systems, it can obviously diversify the economic output because it will increase the income of the farmer who is actually farming this economically valuable unstock fish species. Then the regular common culture fishes and the fishes that they're culturing in their in a regular system in their based on the place that they are from. It increases the system efficiency because like filter feeding species like tilapia can reduce the algal bloom. It can consume the phytoplankton from the systems. We can also introduce different kind of detritivores like the different carbs, which can help in recycling the organic waste, keeping the water quality in balance. We can also, this kind of system can also reduce the risk of monoculture because most of the cases they may not be resilient, and in that case the disease outbreak is quite common in these aquaculture practices. So that can be mitigated if we can supply some nutritionally some productive unstock and resilient unstock fish into our systems. And obviously the crop performance can also be higher. So these are some of the benefits that can be can be witnessed if we supply the unstock fishes in the 3D agri-aquaculture systems. Coming to your first question about the salinity, salinity is a major issue if we talk about the places where suppose we are trying to grow this 3D agri-aquaculture systems near to some seashore area, or suppose near to even the brackish water sources and all. So in that case, yes, it can be a problem. So there are different ways we can actually address those issues as well. First of all, we can select the salinity tolerant species. Like in terms of fishes, if it's freshwater systems, we go for tilapia, catfish, trout. Tilapia can also sustain a little bit of high saline water as well because it's quite rigid in general, but especially the Nile tilapia and all. Or otherwise, if it's a brackish water, if the salinity level goes more than say like 2 to 5 ppt parts per thousand, so in that case the milkfish, sea bass and shrimps can be an excellent choice. If it's a marine system, if your only source of water is from the sea or the nearby ocean, so you better to go for the groupers or the kind of snappers kind of fishes. Crop selection is also like that. You go for freshwater sources there. You go for lettuce, spinach, tomato, like regular vegetables that you can see it in the market. And if it's a brackish water, go for halophytes like quinoa or barley. They can adapt to moderate salinity. But if you see like the salinity level is quite high of the incoming water, so then you should go for the high saline crops like seagrasses or the regular some high cash mangroves are also there that can also be used in the coastal line and all. Again, you can go for different kind of salinity adjustment mechanisms. There are some kind of biofilters with the salt tolerant microbial community is also there. People have already done a lot of research of this halophiles and all. So they work on it and then try to reduce the salinity level before it actually enters to the system. Your actual 3D agri-aquaculture systems. We can go for basic desalination technologies are already there. That RO systems are there which can reduce the salinity for freshwater species and crops. And or if it's really not possible to go for this, then one of the ways that we normally do it only happens when the salinity is well within the limit, just a bit above the limit, not quite high. It's called the gradual acclimatization. we can go for gradual acclimatization of our fish or the crop, and we'll try to grow them, make them survive in that situation, so that they will somehow be able to survive without facing any any drastic issues, drastic problems. And so so another question, if I am correct, you asked me about the challenges that I face, right, in this 3D agri-aquaculture system, right? This is the third question you have asked. Yeah. So if I'm correct that you're asking about the challenges, yeah, I personally face challenges like majorly, if I talk about to start with the basic R&D facilities that needs to be made. And so I did it for the last couple of years. I made my research team aware of the technologies in this regard. I got some grant, and based on the grant, I have developed the system here. And based on that, but if you talk about in general, what are the major challenges it lies for for a normal farmer in our country? So definitely, to start with, they may face challenges like technical challenge. The system is a bit complex compared to the regular agriculture or aquaculture systems. So the water management, species compatibility, this can be an issue at the initially. So you need to have a technical expertise or like an expert available who can actually give you some help in the very beginning of this kind of systems. Economic challenges there, I should agree to that the high initial investment is there in this kind of systems. But the good thing about it, the return period, the payback period is quite less. Okay, while saying so, I'm again iterating. When I'm saying that payback period is less, it depends upon a different variables. Okay, so it depends upon the variables, depends upon how how good of expertise you have, how good of a technical person you have, and how good of a environment and the economical involvement you have in that unit, in the development of your plant or of your unit. This 3D agriculture system. So it depends upon a lot of other variables as well. So in a whole, based on my experience so far, it has a very less payback period. So we don't have to worry about that. Like that I'm taking a lot of loan, and how I'm going to get that money back and all. There are issues with the different governments and different countries, like in different countries, especially not government, like different in terms of the legislation, especially in terms of how to say the grants, or in terms of the proper regulatory guidelines, proper policy guidelines. Those are not available in most of the countries about 3D agri-aquaculture systems, because it's a very cutting edge technology, cutting edge innovations we are talking about here. But if we actually have the proper knowledge, have a proper capacity building, have a proper consumer awareness about it, and definitely with the help of the policymakers and the regulatory compliance bodies, and obviously the experts, we can actually cut it through. We can actually cut it through to the next level and make it quite significant in the field of agriculture and aquaculture practice, especially focusing on the urban environment, urban development, as that is our major goal of discussion today, that how this 3D agriculture aquaculture systems can be utilized in the urban development, especially the smart cities and all. So I hope I answered your question.
Yes, sir. So thank you for the valuable insights. So my question in the context, recently United States Department of Agriculture efforts to promote urban and innovative agriculture production, ranging from vertical farms and rooftop gardens to hydroponic and aquaponic system. So how do smart 3D agriculture systems fit into this evolving landscape? And specifically, how can these technology addressing pressing challenges such as food insecurities, climate resilience, water conservation, and while also foster economic opportunities for small scale and beginning farmers?
Okay, so see, the major contribution, if I say about this smart 3D agri-aquaculture systems that we are talking about, is first of all, in terms of even if we even forget about the USDA, even for Indian regulatory bodies or any other developed or developing countries regulatory bodies, they also trying to initiate this kind of control environment. How to say this? This resilient agriculture systems. Resilient in agriculture in terms of environment resilient, in terms of economic resilient, and obviously in terms of to improve the localized food production and all. So there are a lot of key contributions I can discuss. To start with, this kind of 3D agriculture aquaculture systems, it can tackle the food insecurity issues because it's a localized food production, right? Suppose you have a small city, suppose you have your institute. So just suppose instead of going outside every day to buying the vegetables and the fishes and all, suppose in the middle of your campus, your institute, you have a small vertical garden, vertical building. Inside the building, you have a small vertical garden with all the possible vegetables, like leafy vegetables or the regular vegetables that we normally consume. Along with that, you also have a small aquaculture unit. And this 3D agri-aquaculture concept is actually being used here, promoted there. So you'll have a localized food production. You don't have to relying on, at least for some basic necessities, all the possible fruits and vegetables, fruits, even the horticulture crops can also be grown easily. And Netherlands is showing us the path on that way. The fishes can be grown, which will actually cater the need of the protein intake of our body. So in general, most of the nutrient intake can be somehow being catered by having this kind of small 3D aquaculture systems inside your campus itself. So at least for all the students and the faculties and their family members and all. So this is what not only USDA but also in India also it is being promoted, and most of the countries all are actually trying to learn more into it and trying to promote this kind of smart 3D aquaculture systems. Other than that, we have a benefit of year-round productivity. Obviously, we can have a nutritional diverse product, like we can go for vegetables, herbs, protein from the fish. We can go for address the diverse dietary needs based on our demand. Other than that, we can conserve the water. Basically, in this kind of systems, we reduce the water consumption like anything. We integrate the wastewater reuse, like suppose the grey waters or the grey waters coming out of your urban infrastructures, urban bodies can be treated and can be supplied in this kind of units, and so it will drastically reduce the dependency of groundwater or any other surface water sources for growing the crops and the fishes. Just imagine where the future lies. Other than that, it will reduce the carbon footprint, economic opportunity, like very low barrier to entry as of now, because there is no, the prime movers as of now. We call it prime movers are the startups which are when a sector is not flourish enough. So the most of the startups and it's like low hanging fruits for the early entrepreneurs and all. Other than that, it can also support the issues like unemployment issues in different developing countries, especially. So you can just go and have just convert your rooftop in a 3D agri-aquaculture systems, and that's how you can support your family, and you can actually use it for your economic benefit as well. So what USDA and the regulatory bodies like this they are doing, that is why they are keep on integrating this kind of system, this kind of advanced system like 3D agri-aquaculture systems with their urban agriculture policies. They are trying to address their sustainability goal also by doing so. And they are trying to innovate changes in their education policy. In India also we are doing national education policy. They're trying to change and introduce this kind of advanced agri-aquaculture systems so that people will be aware of it. So the community empowerment can be done, and the training programs and the capacity building can be done so that they will be able to understand more about this kind of units. And obviously there are challenges, as I told you earlier, the high initial cost, technical expertise, scalability, and the regulatory barriers are there, and which needs to be addressed. So frankly speaking, if your questions are done, I'll be very happy. I mean, like to say more in terms of as a developing countries like us, like in India, we need to do some changes in the policies. So that is like dire need as at this moment. Otherwise, this kind of technologies will literally be there in the lab scale only, be there in the in a small, in a closed chamber always. It will not be able to flourish unless until we'll actually make our policymakers move and do some changes in their policy statements and all. We need the financial support and incentives. Frankly speaking, the farmers, I mean, like I cannot just say that, okay, so you go and I just go to a rural villages and I ask the farmer, so, what you're doing, you're not getting much money out of it. Your return average income is 20,000, 30,000 Indian rupees. So which is not enough. So what you can do, you just convert into 3D agri-aquaculture system. It sounds very nice and very, interesting and like futuristic. But what they're gonna do? They need some additional support. They need some support from technical, financial, and policymaker side, and that is what we are lacking as of now. And I hope with time things are changing. A lot of different states in countries like India, they are coming up with the special grants for this kind of 3D setups, 3D agriculture setups, and I hope more and more countries and the states will also actually focus on that and actually help.
Thank you, sir. Sir, I have questions in context with artificial intelligence, which is the hot topic of the today's world. So my first question is, what are the current AI technologies being used in 3D agri-aquaculture systems, and what are the key challenges in implementing of AI? And my second question is, what is the future scope of AI in enhancing 3D agriculture systems for food security? Over to you, sir.
If you are talking about the AI, the artificial intelligence technologies, definitely it's the most hot topic nowadays, and it is very interesting. As a researcher, we also are very much happy and fortunate enough to learn more about this AIs and integrated in this kind of research, the 3D agriculture system research. So your first question was like, what are the different technologies available? And let me answer that first. We know that it's quite known to us, these techniques like computer vision techniques. It helps in, this is one of the major AI technologies, I would say, like which helps in monitoring the health of the aquatic species, the crop health. It detects the pest or the diseases if there is for any aquatic species. Other than that, it also helps us monitoring and identify the abnormalities and measure the growth and the tracking the fish biomass over time, so that we can be able to understand when the fish is ready to harvest or the crop is ready to harvest, or at the same time, so we can easily able to identify the diseases that the crop is being infected with, or the fish started behaving very abnormal. So that means there is a possibility of it actually infected with some kind of diseases, so that we can treat it and we can put it in the quarantine tank and we can treat it at that time only, so that we can reduce the chances of loss of complete stock, isn't it? So that is a major another issue with the aquaculture is like they don't know overnight. We're dealing with the living bodies, right? So living animals, right? So they don't know overnight. They won't be able to understand, and you can see like all the fishes are dying and like just simply floating on top of your pond or the tank. So these are like quite common issues like aquaculturists face. So this kind of issues can be easily catered by using the computer vision techniques, and people are working all over the world in this regard. People are working on this IoT based, Internet of Things based in integrated AI systems for using the different sensors for the water quality and understanding the water quality like pH, dissolved oxygen, temperature, and other environmental conditions as well. Another current artificial intelligence technologies that we can discuss about is like the IoT integrated systems. We know that Internet of Things, which are normally used for collecting the data for the water quality, especially pH, dissolved oxygen, temperature, and other environmental parameters as well, to predict the trends and provide the recommendation for optimized values and all. So it has been done in our lab as well. We are working on it and we are trying to find out that how water quality is actually affecting the not only the fishes but also the crop biomass as well. We use the different predictive analysis and the machine learning algorithms for forecasting these water quality changes, and also to predict the outcomes and suggest any preventing measures if it's needed. Different robotics and autonomous systems are also nowadays on the plate. AI-powered robots are used for feeding, cleaning the tanks, harvesting. Drones are used for the aerial monitoring of the agricultural crops. NLPs are there, natural language processing algorithms, where the chatbots and virtual assistants are there, which can be helpful to the farmers or the agricultural managers to provide the real-time advice based on the AI analysis of this for their 3D agri-aquaculture systems. Other than that, there are this digital twin concept, like you just have a virtual model of your 3D agri-aquaculture system, and then AI will simulate and predict the system behavior so that you will be able to plan better and your decision will be more optimized. So these are the things that nowadays current AI technologies that is being used in 3D agri-aquaculture systems. And the challenges, if you ask me, definitely the data collection and the quality is very difficult, because to getting a consistent and high quality and the proper labeled data set for training this AI model is difficult, especially in living system like 3D agri-aquaculture systems, because there are like lot of environmental factors and the variability that makes this standardization is very challenging. Cost and accessibility is also an issue, and obviously the knowledge, the user training is very difficult. You cannot just ask your a farmer, agriculture or aquaculture farmer who doesn't have much academic knowledge. You cannot just ask them to use this kind of AI tools more fluently. It's very, and also it comes with a lack of trust and understanding also. So it's very difficult for in that regard. And other than that, obviously regulatory and ethical concerns are also there sometimes, that AI is actually taking our job away, which is a very hot topic of discussion nowadays. And and power utilization is also, the energy utilization is also there, which is also an issue. So these are the issues that obviously are there and needs to be fixed, and the solution is there definitely. But I should be frank with you that still we are a bit away from getting a successful outcome from always utilizing this AI. Definitely there are a lot of benefits, but it's still in practical applications needs to be more thought after. That is what is needed. If you ask me about the future scope of this kind of AI in 3D agri-aquaculture system, as I told you earlier, like we can manage the resources quite precisely using the artificial intelligence. That is the best thing. Water, energy, food, feed, whatever we are supplying can be managed very precisely by so we can minimize the waste and maximize the yield, right? It used for disease and pest management. We can easily detect the disease in early stages, and we can actually minimize the chances of failure of the system. Obviously, we can design the climate resilient systems. We can integrate it with the diverse farming practices easily. It's not only that AI can easily tell you that how you can seamlessly integrate the aquaculture, agriculture, and vertical farming in these 3D systems, which particular component is more significant and which point of time, and which type of nutrient needs to be provided at which point of time, so that the crop will be or crop or all the other three strata. Here in 3D agriculture system, there are three strata which is involved, living strata, right? First, fish. Second, the microorganism present in your bioreactor, and third is the crop. They three are the major strata that is involved here, and which needs to be treated, which needs to be arranged properly. We need to arrange the nutrient properly so that they all feed properly to get the higher output, high yield. AI can give us a personalized farming system based goals also. Like if we want organic production, if we want to reduce a particular type of input cost, so we can we can just supervise the model, and it can actually give us the certain conditions, and based on the demands we can get the final output, optimized output, I would say. And obviously we can enhance the productivity. We can improve its different high variety crops only we can supply, so we can genetically improve their quality, and only we know that at this particular environment this particular type of crop will give the best results. So we'll just do that based on their suggestion, the suggestion given by the AI tools and all. And obviously the environmental footprint is reduced because of that. And in a way, that is why I'm saying that this is the future. Like, this is how the AI is actually helping. And though in this 3D agriculture system, the final the value that it's not visible yet. The outputs are not at all visible yet because it's still in the laboratory scale. But I'm really hopeful, and I'm 100% sure that in the coming decade, India and countries like India, like all the developing countries especially, they will definitely come forward and they will take it as one of the major solution for the nutrient demand of their urban population, and they can actually use these AI tools to make it to the next level.
Thank you so much, Dr. Gourav. I think it was very comprehensive, and I'm sure our listeners have got a required privilege to listen to you and get to know more about this 3D agriculture ponic system. Sorry, I think I reversed it. It's Agri-Aquaponic concept. So, Dr. Bhowmick, I think thanks again for such an insightful talk on this technology, and how influential it is in today's life to understand such emerging technology, and especially the aquaponics, which is how such system could be integrated in the smart city mission and developing the urban sustainability visions that we all are aware of, and how we can achieve its goal via this great 3D aquaponics concepts in line with the economic benefits that you have cited, the energy saving envisions for long-term environmental based city planning approach, and also the discussion happened on the benefits of it started with the benefits of recirculating aquaculture technology, where you discussed about the byproduct essentials and how we can, kind of say, basically another term of byproduct that I use in my research is the downstreaming technologies, and how it could be recycled into the main system, which is very important. If we understand the circular economy of any technology, it is very important to understand these concepts as well. You also aligned this technology and I think discussed its link with waste to resource, and of course the circular economy and its importance of reducing the dependency of the resources and overall impact on food security, which I'm sure that most of us would be linking it with the food security, which I think you have made it very, very clear that how important it is to see things in another way. And you also enlightened our listeners, I hope, about the importance of process conversion in the 3D aquaculture system, using innovative bioreactor systems such as microbial electrochemical systems. And we must promote such sustainable technologies at a higher scale in this field of research. Our discussion continued on modular farming, which I am, as a keen learner, Dr. Gourav, will definitely read about it once I'm back home today, as I found the discussion very practical and feasible. We continued our discussion in detail regarding the benefits of supplying the intact fish culture, which cohesively included, the balance of water quality, risk of monoculture, and of course, the importance of disease outbreak that may likely to happen. And we continued our discussion on the importance of halophile, which was an associated question from one of our audience, which can possibly tackle high saline water, these halophiles, especially in the agri-aquaponic system, which I'm sure is a great content and a scope of modern day research in many other fields also, because we keep talking about the halophiles, which could possibly remediate the high salinity conditions, and so that we get a better condition to work on. A great insight was also received in terms of the economic challenges and the hope of high returns associated with these emerging technologies. The importance was also laid on the role of policymakers in the sector of urban development, like let's say smart city mission projects, and some good people coming in and joining the mission to understand this feasibility and sustainability of these emerging technologies. A good round of discussion also happened on food security, like I mentioned earlier also, and like many of us may question regarding this element of research. But you made it very clear that by adopting such 3D agriculture concept, how this can be taken care of. Of course, there are some associated challenges, but a very good policy making approach can help us in translating the research and development work from lab to field. We continued our discussion and ended up with a very curious topic of modern days research, which is the artificial intelligence, and how interestingly, there exists a scope of research in such an integrative research measures, especially the 3D Agri-Aquaculture System. How AI simulation can help in optimization of the data by also citing the challenges, the lack of trust and ethical concerns, as we know that it is not as simple as we say that, training and validation will be done and, things is going to work as we define the model. So there are some concerns, but I'm sure that these real biological system would need a very better way of sensing and, should not just rely on the AIs for sure, but also understanding the challenges of the biological system. And Dr. Gourav, I think there was many things that I personally wanted to ask you, but because of the lack of time, and I'm sure the audiences would like to reach you after this podcast whenever it will be broadcasted, and I'm sure that they would want to reach out to you personally via email or social media. So a big thanks again, Dr. Bhowmick. I think it was absolute pleasure to host you on E2C podcast session. Thank you, Dr. Gourav.
Thank you so much, Dr. Pratik. The pleasure is all mine. I really like the initiative that you have taken and the whole team, the way they are continuing this initiative. I hope great success to this podcast series. And thank you so much for having me here today.